practice test. Kind of goes through 2x2s, 3x3s, a couple story problems, a couple systems of linear inequalities, and then some nonlinear systems. So the first three are 2x2s, which means there are two equations with two variables in which each equation itself is just a line. So it's a system of linear equations. On this first one, I want you to use substitution. So I looked at this bottom equation and I solved for x. I say that x equals 2y minus 4. And then I'm going to take this value here of 2y minus 4 and I'm going to put it in for x, which is what I do right here. Distribute this and I solve for y, right? You just get 10y equals 30, divide by 10 and get y equals 3, and then you can take and go right back up in there and put in a y value of 3. 2 times 3 minus 4 is 2, and then you have the solution to the system, the point 2 comma 3. You could check your answer if you wanted to, plug it back into both of the original equations, and you can show that it is the solution. Next one, elimination. This is elimination because look how nice they're lined up. X's, Y's, equals, numbers. I decided to eliminate Y. No reason. I could have eliminated X. I multiply the top equation by 4, which is kind of what I'm telling you to do here, and the bottom equation by 3. That will give me a negative 12y and then a positive 12y, and then when I add these equations, then, excuse me, then I'm going to eliminate y, and then I'm just going to have x. So when you do that, you get 26x equals 104, divided by 26 to get x equals 4, and then you can take the x value of 4 and you can plug it in there, or you could plug it in there. It wouldn't matter in that case. It looks like I plugged into the bottom equation and put x equals 4 to give you 8 here, subtract, and then divide. And you get the coordinate point 4 comma 1. Again, you can check that it makes both of those true statements. Then solve by graphing. So this is just the line with a slope of 2/3 and a y-intercept of -6, which is what I did done this blue. And this is the green. This has a y-intercept of 4 and a slope of -1. So I draw that, and it looks like they intersect at the point 6 comma -2. You can confirm that by plugging the point in here and here and getting true statements. Again, solving by graphing is the intersection of those two curves. We want to know when these two things are equal. All right, this is the system of linear inequalities. This is me graphing the blue. The blue has a y-intercept of 1 and a slope of 3, which is the blue line graphed here. This is the green. The green I had to do a little work to solve for y. And I get a y-intercept of 2 and a slope of -1/2. And since I want y strictly less than, it's a dotted line, dot, 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 or dashed. And then this is x is greater or equal to -2, so I draw that vertical line. Okay, now let's think about the shading. Okay, so if you go to the blue and you go on the line, and if you go up, then you got this region. So all of this region is the blue. The green was down, so go to a green point and go down. So then all of this is the green, and then x is greater or equal to -2, then you need to be right. So I needed to be above the blue, below the green, and right of the orange. And so the shaded region there is the solution set. So all of those points in there, all the points on the blue line, all the points on the orange line, all the yellow points, and just make sure you don't include points on the green. All right, here is the 3x3. I did that same process and I color-coded it the same. It looks like I'm eliminating x. I could have eliminated y. Z would have been tricky to eliminate because this is like a 4 and a 3 and a 7, but let's do the x. So I took the top two equations, and it looks like I multiplied this one, the middle one, by -2, and then I could add the equations and get rid of x using elimination. Then I did the red, so I looked at the bottom two equations, and I multiplied the middle one by 3. That'll give me that will give me a 3x there, which will work well with my -3x in the bottom. So multiply everything in the middle by 3, add the equations, and then I have these two right there. The 11y with z and the 13y with the z's. And then I do elimination there. Now that one is just nice. That's just easy because this one already had a -2z and that had a +2z. But if I needed to, I would have to multiply both of them by something in order to create opposites. In this case, the blue plus the red is right here. It eliminates z, I get y. Once I know y, I can plug back into the red there or the blue there, and I can get x value. It looks like I plugged in right. Oh, where did I do that? Looks like I plugged that in right here. I did the purple, and then I did the orange to find x. So y value, x value, z value, so it's 1, 2, 3. All right, nonlinear systems. You are almost always going to use substitution on nonlinear systems. So I take this x value and I say, all right, well, if x equals 3y plus 5, I'm going to take that and substitute it in for x, which is what I do to get this line right there. 3y plus 5 squared plus y squared equals 25. Remember, you cannot look at this equation, x squared plus y squared equals 25, and think you can square root individual terms. That is not a true statement. You can try numbers, but you cannot take the square root and think that this top equation is the same thing as x plus y equals 5. Not true, okay? You can take square roots of sides of equations, but the square root of x squared plus y squared is not x plus y. Think that through. It's the same reason that if you try to square x plus y, you don't get x squared plus y squared. You get x squared plus 2xy plus y squared. Okay, so I FOIL this, I get this, and then I end up with a quadratic. And I get everything to one side, and at this point I can factor, I can complete the square, I could use the quadratic formula, but I just factor, and then I say, okay, if this times this equals 0, then I know this is true when y is -3 and when y is 0. Both of those values of y make the equation equal 0. So I get those two values of y, and I gotta plug into the linear equation. Don't plug into the quadratic, or excuse me, to the circle, because when you square things, you get some issues. Okay, so plug it into the linear one. So 0 into y gives 5, -3 into y gives -4. And if you looked at the graph, this is what it would look like. It would intersect at the point -4, -3, and 5, 0. Just be clear that these are the y values, these are the x values. All right, same thing here. This time I have a parabola and a line. I solved for y using the line, right? I used this guy, solved for y, and got this guy right there. And then I substituted that in for y to the other equation, and then I solved that quadratic. The quadratic does factor and gives me factors of x minus 2, x plus 1, and I know that's equal to 0 when x equals 2 and x equals -1, and I took those and I plugged them back into the linear equation to find these two solution sets, right? So 2, 3 is this point, and then this point is -1, -6. Same thing here, substitution. I took this linear equation and I know y equals x plus 7, so I just put x plus 7 in for y. And then I'm going to subtract by 5, then divide by 3, then, and only then, when I get to this point right here, then I'm going to look at the two branches, because this is an absolute value. I'm going to say, okay, x minus 2 equals the positive version, x plus 2 over 3, and then x minus 2 equals the negative version of that. So I distributed the negative sign and made it minus x minus 2, and then I took that 3 and I multiplied it to the other side and got 3x minus 6, and then I just solved. I get x values of 4 and 1, and I found y values of 11 and 8 because I plugged them back in to the linear equation. Okay. On the absolute value ones, you probably do want to check to make sure whether you have an extraneous solution. So make sure that this guy works and this guy works in both equations. Remember, absolute value and squares have some issues sometimes with negatives. So make sure we plug back in to both equations and make sure they both work, which they do. Okay, so I give you the hint, hey, go and use your calculator. So you could have just graph this and find the intersection. You could have graphed this and graphed this. Now, you can't graph this on your calculator, but you could have graphed it on Desmos. And yeah, you could have graphed this one and got this. All right, now we got story problems. And again, this is the idea of distance equals rate times time. This is an important concept. This is, something you probably discussed starting in 5th and 6th and 7th grade, of how far you go is simply how fast you were moving times how long you did that. And so we have to know about downstream and upstream with a current, which would be the same thing as like running into the wind and then with the wind. When you go with the current, you go faster. And when you go against the current, you go slower by that amount. So my variables here is B is the boat and C is the current. So when I'm going downstream, I get the boat plus the current. That's my rate times 2 hours, and I went 32 miles. And then upstream, my boat minus the current is how fast I'm going. The current is hurting me, and it took me 16 hours to go 32. So I divided both this by 2, I divided this by 16, and I get these two equations, and it's actually really fast to solve for the boats, how fast the boat can go, and then how fast the current can go, and then you can kind of figure out, oh yeah, the boat with the current is going to be going 16. 16 times 2 hours would give you 32 miles. The boat against the current would reduce your speed only 2. 2 miles an hour for 16 hours would give you 32 miles. And so you can always check your answer. This is a roller coaster, right? You got a roller coaster, it's got 15 cars. So you know the certain cars plus the other cars equal 15. And then you got 4 passenger cars and 6 passenger cars, and you had 72 people. So you can just solve. And it looks like I solved with elimination, and I got 6 and 9. Okay, this one, you got 3 different condos. So you got a 2-bedroom, a 3-bedroom, and a 4-bedroom. So I call those condos A, B, C. And I know that I got in $1,240 rent. So the rent from all 3 of those together has to be $1,240. And then it tells me for repairs, 10% of A's went to repairs, 20% of B's went to repairs, 30% of C's went to repairs, and I had $276 worth of repairs. And then it does tell me that the 3rd bedroom rents for twice as much as the 1st bedroom. So I know that C equals 2A. And at that point, you got some system. It's a 3x3, solve it however you want, but this is the solution if you want to check it out. And then the last one, I got Edwin, his father, and his grandfather. Just call them the 3 variables. And I know that Edwin plus his father plus his grandfather divided by 3, that's the average. That's how you find the average of 3 numbers. Add them up and divide by 3 equals 53. So that's the first one. And then 1/2 his grandfather's age plus 1/3 the father plus 1/4 of Edwin is 65. That's this line. And then if 4 years ago, that's this, C minus 4, Edwin's grandfather was 4 times as old as Edwin was. Well, Edwin was 4 years ago. It is A minus 4. And again, this is a system where you have 3 variables and 3 equations, and go ahead and solve however you want. Okay, certainly on the test, you will have to solve 2x2s, 3x3s, linear inequality systems, nonlinear systems. You're going to have some story problems. Some story problems might say solve, and some might just say set up. But you certainly have to be able to do both of those things. Take a look at all of these, and we also have a review that we'll do next week.